Ever wondered how a house price is determined? What factors really matter? So let us try to uncover the mystery by building a machine learning model to predict the house prices of Bangalore using a real data set from KAGGLE. By the end of this video, you will be able to understand the factors on which the price of the house is dependent on, and you'll have a code to predict it for yourself. This entire project is divided into two parts. In this part, we'll be building a model and testing until we get a satisfactory result. In the next part, we'll focus on web application consisting of a simple user interface and an API to communicate with the user and the model. For Bangalore house prediction model, I'll be using Jupyter notebooks. I assume that you're having knowledge on Python's basics and also some of the important functions in NumPy and Pandas. Before building a model, we have to have a clean data for the model to process on. For this, we'll be doing 5 key steps. First one, data pre-processing. Look in the table, understand the problem we need to solve. That's it. Second one, missing values. Generally, all the tables collected from a real data set will have missing values. Decide what to do with the missing values. Third one, data formatting. Not all data is going to be the right format as you want. So we have to change the data types using some functions or create our own functions if needed. Data normalization. Price of the houses are going to be exorbitantly high or low, but model does not like these high ranges. It needs a suitable smaller ranges. So we need to normalize the given high range data into smaller ones. The most important them of all is model does not prefer text attributes. It needs numerical attributes. For this, we'll be converting all the categorical, if not most of the categorical attributes into numerical using some of the important functions in Pandas and NumPy. So let's start coding now. And this is the CSV file from this KAGGLE dataset. So what is the first step? Data pre-processing. Look and understand the table. For this, we have to import the table first. But before that, let's import all the libraries required for this project. Okay, and now let's import the table. What is the CSV file name? Bengaluru house data.csv or data with a D capital. Checking its first 5 rows. Here we can see area type, availability, location, size, society, and these all are. Let's check its info. Here we can see the maximum value being 13,320. Here we have a null value. Here a couple of 700 or so null values. And we can see many null values. And yeah, the first step is over. Second step, missing values. Here the first column, area type, there is no null value. Second column, no null value. Third column, we can see there is one null value. So let's check the unique values of that. df of location. What value counts does? It takes each value and counts them, how many times they are repeating in that column. You can see Whitefield being the highly most repeated in that location column. So let's replace that given Whitefield, the null value in location column by Whitefield. And it can also reassign it. And reassign it. And reassign it. So the first column location is over. Moving on to the second column. And in the sense, second column with null values. Size df of size dot value counts. Oh, we can see the highest most common ones is 2 BHK and 3 BHK. So how many null values are there? df of size dot is null. So we are having 16 null values. Let's assign it to 2 BHK. Df of size dot fill in a to b BHK, and again reassign it to the data frame df of size. Okay, now the second column is also over. The third column. What is the third column? Society. In this, we can see that there are around more than approximately half of all the data is missing. So let's just drop it. Dropping is simple using pandas. So we type the column name over here. What is the column? Society. There it is in axis 1, in the sense column. We also need to mention in place equals to true. What this does, it directly updates the given data frame without having the need to reassign it back. Total square feet. Here we can see all our not null values. In the sense, all are filled, but we are having around 50 null values almost. Let's just check how many null values are there. For some reason, it's not working now. Yeah. Bf of that dot is null dot sum. So we are having 73. Let's assign it to its mean. Bath dot till na its mean. How we can calculate mean? By writing its series object of that column and the mean function. I think we need to reassign it back. So this confirmation, let us check how many null values are there in bath column. Is null dot sum. Okay, 0. So bath is over. Balcony. Balcony also, let's assign it to its mean. Mean for balcony. Df of balcony. Df of balcony dot fill na. Df fill all the non-null values with its mean. Next one, price. We can see there is no null values. Step 2 is over. Step 3, data formatting. What do we do in this step? We'll check the data type of the given column and make sure it is in numerical format. If it is not in numerical format, we convert it into numerical. Okay. The first is object area type. Object, it's not numerical. So let's convert it into numerical. How do we do that? For some reason, again, it's not working. Let's check the unique values of area type. Area type dot value counts. So only 4 columns are there. We can convert these into unique columns by using one-hot encoding. What one-hot encoding does, it takes super built area and built up area. These all makes it into columns separately and gives each value a Boolean value. So for all these 8790, the column super built up area will be true, and for rest all it will be false. So for this 2418, the built up area column will be true and other 3 will be false. It's like that. How do we do that? We create a dummy variable and assign it to the return value of pd.getDummies of this column area type. Then pd.concat. What it does, it concates our original data frame and this newly created dummy variable. How does it connect? It connects on the column. It connects on the column. Okay. Now, as we are having these dummy values as columns now, I mean, as these super built up area, these all are columns, we are not having a requirement of this area type. Let's drop this area type. Area type. We are dropping it from column. And make sure to add in place equals to true. In place equals to true directly updates the data frame. There's pd.get typo. It get dummies. Okay. Now let's just check how the data is right now. There's no error here. The error is I did not reassign it to the data frame again. So let's run it again. Okay. And now assign it to the data frame again. Now it has come. Okay, now moving on to the next column. Availability. It is also object. Now what is there in availability? Availability. Dot. We're having a couple of dates and some strings. Okay. So we cannot directly convert these dates into columns. So what shall we do? Okay, yeah. Let's reassign all these dates and group them into months. And how might we about to do that? Okay, for index comma val in no. But for okay, index comma val in. So what am I doing here is I am iterating through all of these each values in df of availability in the availability column. Making sure availability spelling is correct. Yeah. Now, if this value starting from its third index is in this list, what is this list? This list is going to be each of the month. Okay. Each of the month. If that value starting from third index is in this month, then we are going to update that index of the availability column to the month. So here we can see 1 is in 0 index, 8 is in first index, this hyphen is in second index. That's why starting from third index to full. And rest all we are not updating. Okay, now after this, let's check how the columns are right now. Too many variables unexpected to. Okay. So here dot items is needed. Yeah, we can see that the dates before has gone and nothing has happened to this. Now let's check the unique values of this availability column. It should have been greatly reduced because as we group them into months. Yeah, as we can see. Now let's make this into numerical. Again, we create a dummy variable, pd.get dummies of this column. What is this column? Availability. Now again, reassigning the return value of pd.concat. We are concatenating the original data frame and this dummy variable. How? On axis 1, in the sense column. Now we are not having the requirement of this availability column. Let's just drop it. How are you dropping it? Axis equals to 1. And do not forget in case equals to true. This directly updates the data frame. Now checking the first 5 rows, we can see there's no availability column and also January and everything has been added. Okay. Now the next column, availability is over. Now location, this is also object. Okay, for location, checking the unique values. Location, non-value counts. There are 1305 unique locations. This is very big. So what shall we do? Here for that, I'll come up with an idea. And yeah, here there are many unique locations like Whitefield, Sarjapur Road, and Electronic City. And upon examining, there are more electronic cities. Electronic City, phase 2 and phase 1, many. So what I'm doing here is grouping all the Electronic City and nearby clusters to this group. Then Whitefield and its nearby clusters to this group. Like this, moving on for KR Puram and East, grouping all the KR Puram and nearby areas. Similarly for all the data and creating a function. What this function is going to do, it groups through all of each of our locations in this column, in location column, and then strips it. Stripping in the sense removing all the spaces from left and right. After that, it searches through each of these lists. If it finds if the location is in any of these lists, it updates that given location into its group. For example, Shampura will be updated into others. It's like that. And after that, we are using the unique to display all the unique attributes of the location column after the updating. And also we are checking the null values if there is any. Running this shows greatly all the locations are reduced and 0 null values. Now let's assign it to, let's again make this into numerical attributes. EF of location. Now this time there will not be many locations as in the previous case. Reassigning the return value of pd.concat of, we are concatenating a data frame and the dummy variable where on axis equals to 1. Now what are we going to do? df.drop. What is df.drop? It drops the given column. Now what are we dropping? Location column from the column section axis equals to 1, and do not forget in place equals to true. Let's check the head. Now let's check how many columns are there and what are the columns. Okay, yeah, we can see all the groups are added into the columns. Now let's move to the next. Okay, now size. Size is also object. Let's check unique values of size now. So you see the pattern, right? It's similar to all. Oh yeah, we can see so many 2 BHKs, 3 BHKs. Okay. Now we cannot directly convert this into columns because here we can see 3 BHK and 3 bedrooms. Both are having 3 bedrooms. The only difference here is 1 hall and 1 kitchen. Here there is no hall and kitchen. For this, I made a function. Yes. Here we can see this is the regex pattern of this BHK column, BHK attribute. And this is for the bedroom attributes. This is for RK, room and kitchen, similar to this. Now, this unwanted text remover, what this function does is, it iterates through each of our column, here size column, and then compares it with this pattern, and this pattern. If there is any match for each of this, it extracts this text. After extracting that text, for example, in BHK, here we can see 19. df.log index comma bedroom. Here this number is that 19. And hall and kitchen are 1 because it's BHK. 1 hall and 1 kitchen. Then for the bedroom, plain bedroom here, 43 bedrooms. Bedroom is 43 and there are no hall and kitchen. So 0. And in 1 RK, 1 room and kitchen. So bedroom is 1, kitchen is 1, hall is 0. We apply this function on this column. Now let's check df dot columns. So we should be having bedrooms, halls, and kitchen. It's running. This star represents this cell is running currently. Okay. Okay, now it's run. Here, where's bedroom, hall, and kitchen? Yeah. Bedroom, hall, and kitchen. Here you can see 3 new columns are added. Okay, now this column is also over. Okay, no. I think we have to should drop size. So let's drop size. df dot drop, because this size is not much useful for us right now. Again, x equals to 1, in place equals to true. Do not forget this in place. Okay, now next one. Society. Society was already dropped before. Total square feet. Okay. Let's check unique values in total square feet. df total square feet dot value counts. One thing good about unique values, one thing good about value counts over unique values is that value counts not only gives unique values but also counts. So value counts is more better. Okay, here we can see a range. For this kind of range, what's preferred is take the left value and the right value, get its mean, and then assign it in place of this range. Now for this I have created a function split mean. What it's going to do, it's going to take this range, splits it based on this hyphen, gets its both values, value 1 and value 2, performs its mean, and then what it does, it assigns this mean to the copy of the column. If the given value is not a range, it goes to the else block. In else block, it tries to convert it into float. If it is not able to convert it into float, it drops that. Now, let's apply this function in our, what is it column name? Total square feet. Total square feet. Function name split mean. And let's convert explicitly to float. Feet dot as type. As type function converts it into your given data type. So in middle, you have to check if there is any null value. Okay. Here bedroom, hall, kitchen is having null values. Total square feet is also having null values. We are yet to operate on that. These are having null values. Okay. Okay. So this or call in bedroom, hall, and kitchen. Null values are, are in float. Should be in float before removing. For that, what should we do? Convert the entire column into float so that even the null values are also in float. Okay, now let's update the null values to its mean. Of all dot mean. Okay, yeah, now it's updated. Let's check for null again. Is null or sum? Yeah, now it's cleared. Yeah, and we also can see 46 null values in total square feet. For this, we had to remove 8, correct? Df is equals to drop NA. Set equals to total square feet. This is the syntax of dropping columns. And now, yeah, one thing to note over here is generally for a single bedroom house, the minimum square feet available in Bangalore is 300. So it means 3-bedroom houses having 150 square feet is not at all realistic. For that, we have to remove all those data where the total square feet per bedroom is. We need only those realistic values where total square feet per bedroom is at least 300. How do we do that? We create a new column, square feet per bedroom. We'll assign it to the real return value of total square feet divided by bedroom. And then we'll update data frame to only those columns where this total square feet per bedroom is greater than or equal to 300. And then drop this new column. And then access is equals to 1. Do not forget the what in case equals true. And then let's also check the first 5 rows. Okay, now we have updated all the okay, now we have updated now we have only those data where square feet per bedroom is greater than 300. Next column is price. What should we do for price? We will take the price and then log transform it. What is log transform? It keeps the distribution of values intact but reduce its skewness. Now how to convert it back? np.expm1 of the price will give the original price back. Okay. Now this completes the data preparation. Now we shall do the exploratory data analysis. For this, we'll start with the correlation matrix. correlation matrix. Yeah, it's pretty big and definitely hard to understand. As we need only price, let's check correlation matrix for price. For that, we take the core matrix, access the price column, and then sort its values in decreasing order. Ascending equals to false. In decreasing order, we see that the number of bedrooms plays a unique role, and bathroom and total square feet. These all are major players in determining the price. We also see that location also plays a decent amount of role, where Rajaji Nagar and Malleshwaram means the price of the house is going to be high, whereas Electronic City and other locations make the price go cheaper. Okay. Now let's form a heat map for this. Heat map we use Seaborn. Okay. Okay, for that df dot core and access its price call as a 2D data structure, and annotations equals to true, and okay, this is still not much readable. Okay, let's create a bar chart representing all the unique correlations for the price column. Here is the code for bar chart. Okay, yes, this is more readable. Kitchen, this is different. Higher the number of kitchens and lower the price. Yeah, as expected, bedroom, bathroom, and total square feet and plot area. These are the major contributors to price. Okay. And also the month of delivery date also played a major role. Wherein March. March ones are more expensive. Let's create a scatter plot for total square feet and price. Here we can see the as the total square feet rises, price increases in a very high rate. And we also see many outliers over here. What do you remember when we say outliers? Box plots. Correct. Let's create a box plot for total square feet. Yep, there are many outliers here. This ends the exploratory data analysis. Now let's move on to modeling. For modeling, we have the given data and we need to separate this into training and testing set. Using the train test split function. Of what are we doing? Df dot drop price and then df of price and then test size can be around 20%, random state equals to 0. Okay, it's running. There seems to be an error. Price not found in access. Yeah, we need to mention the axis also. Axis equals to 1. Okay. And closing brackets goes here. Yes. We'll be training it on 5 models. They are, we'll be testing it on 5 models. They are linear regression and polynomial regression, ridge, lasso, random forest, and XGBoost. Okay. Let's start with the linear regression. And okay. That dot fit x and then z dot predict x test MAE equals to x test equals to mean absolute error of y test y predicted, and s is equal to mean square error of y test y predicted. Then R2 is equals to set dot support of x test y test. And MAE MAE MSC MSC R2 R2. Yeah. Y predicted is only okay, yeah. Y predicted. Okay. Here we can see 55.9 R2. For each model is going to be pretty much the same. So I'll explain code for this and then skim through the other models. Here I'll be creating a distribution plot. Here one axis represents the actual values of the y-test and the other axis represents the predicted values. Here you can see predicted and actual values. And now what I'll be doing is I'll be storing all these 3 data to a data frame and then showing you the final bar graph to check which is the best model. From this, we can see that XGBoost 200 is the best model. Why? Because minimum mean absolute error is the least and mean squared error is also the least and R2 score is the highest. That's why XGBoost 200 is the best model. So let's check the second best model also. MAE brown color. What is brown? Decision trees. Here also brown color decision trees. Again decision trees. So decision trees is the second best model. And what is the third? Here, blue and blue and blue, linear. So the rank of the model goes 1, XGBoost, 2, what is the second one? Decision trees. What is third? Linear. If you want, you can check the values over here. So for XGBoost, it's 0.80017, 0.76, which means 80% our model is predicting correctly. And decision tree 76%, linear 72%. This is the worst model. And these three are almost similar. So yeah, by doing this, our part 1 has been completed, wherein we have created a model which can predict the Bangalore house prices with 80% accuracy. This is pretty satisfactory result. Okay. Thank you. Thank you for watching this video. If you have any doubts or questions, please comment. And also for supporting, please consider subscribing. Thank you and peace. The notebook. This notebook is available in the description also. So please have a look at this notebook. If there is any advice or suggestions you want to share, you can comment below. Thank you again. Bye bye.